Okay, so hello everyone. In this video, we'll be showing the question number 3517, which is the smallest palindromic rearrangement, part 1. It is marked as medium. The question is easy to understand. Also, the constraints are very well within the limits. So, what our timeline would be, we will first understand the question, examples, and then try to find a pattern, and we will be solving this question using two methods, and that method are used to achieve that pattern that we will find. Okay, so our main concern will be to find the pattern first and then the pathway to achieve that pattern. Okay, so let's first understand the question, what it wants to say, and then we will move to the examples. Okay, so we are given a palindromic string s. Okay, and we need to return the lexicographically smallest palindromic permutation of s. Okay, so we are given palindromic string s. Let's first jot down whatever things we have understood, because writing down those things will be very helpful. Palindromic string s. So first of all, what is a palindrome? Suppose we have one string like a b c d and c b a. So then, if you try to read it from left to right, it will be A, B, C, D, C, B, A. And if you try to read it from right to left, it will still read the same, spell the same. So we can say that if a string is read from left to right is same as when it is read from right to left, it is considered palindromic. We can think of one more way to describe palindromic. Suppose we take its mirror image. Its mirror image will be, okay, just a second. A B C B C B A. What we have done is we have found its mirror image. This A is over here, this B is over here, this C is over here. Likewise, this B is here and this A is here. So we have found two conclusions, that when it is left from left to right, it is equals to its right to left reading, and it is equals to its mirror image. And we have one more pattern, that when we take a palindromic string, and when we partition it from its middle, the right part is equals to its left part's mirror image. The right half is the left half's mirror image. Suppose we take another example, A, B, C, C, B, A. In this case, we will do the partitioning from middle, which is here. So you can say that this right half is the mirror image of its left half. So we have three conclusions, that left to right is equal to right to left. Okay, these are conclusion number one, that mirror image mirror images are equal. And third, when partitioned, both halves are mirror images. Okay, these are the three conclusions that we have found for a particular palindrome. Okay, now where were we? That we need to return lexicographically smallest. Let's first understand what is a lexicographically smallest. Let's give one arrow over here. And now we will understand what is lexicographically smallest. Okay, so suppose we have one string like a b c x y z. No. Our string is x y z and a b c, and we have another string like x y z a b b, or suppose as of now x y z. So we can come when we try to compare these two strings, we see that the first three terms of both the string are equal. But when we try to compare the fourth term, we find that there is no fourth term of xyz. So we conclude that xyz is smaller than xyz abc. Why? Because it is smaller after equal parts are over. Okay, but what if there are no equal parts? Suppose we have one more, like we take a, b, and a. Here, when we compare the first term, 1, 1, a, both are equal. Now we try to compare the second term, which is b and a. We find that a appears before b. In alphabet, a appears before b, so a is smaller than ab. Why? Because a is less than b. Why? Because a appears before b in alphabet. Okay. So we take consideration of appearance in alphabet as well. Okay. So this is what we mean when we try to think of lexicographically smallest. That is, first we check if that particular number is appearing before that particular element, another element. If yes, then okay, the one appearing before is smallest. But here in this case, if particular starting prefix part is same and one of the term gets over, the smaller term will be smallest. Okay, so let's link this over here. Okay, now another condition is that lexicographically smallest palindrome. Okay, now we will compare lexicographically only, but our main concern will be the palindromes. Okay, so ACCA when compared with CAAC, we find that first A smaller than this A is smaller than the first occurrence of this. So here only we can say that ACCA is less than CAAC. Okay, so this is what is meant by that both should be palindromic, and we just need to find a smaller one. Okay, and palindromic permutation of S. Okay, suppose our main thing is to understand the question only, and we are given that S is a palindromic string. So S, let's take example of A, B, C. No, B, C, D, A, B, C, B. What we will check is first, is it palindromic? How do we check? How do we check that when read from left to right is equals to it right to left? Okay, that is the true case. When we partition it from middle, the right half is its a mirror image of its left part. It is also true, and mirror image is also equal. Mirror image of this entire string is equal to. Okay, it is correct. Now we need to find its permutation. Now you find its permutation. Permutation is nothing but rearranging these terms. Rearranging these terms or elements present in this. So one of the permutation would be AA, BB, CC, DD. Okay, but we want lexicographical smallest palindromic permutation. So is this palindrome? No. A, B, C, D, D, C, B, A. Is this palindrome? Yes, this is palindrome. So this can be considered as a palindromic permutation. This is a permutation, but this is not a palindromic permutation. Okay. Okay. So now let's what we have understood till now is for for a particular string to be what you can say palindromic, its left to right and right to left should be equal, its mirror image should be equal, or when it is partitioned, this is the main thing that we are targeting. When it is partitioned from middle, its left half should be the mirror image of the right half. If this is the case, this is the case, when we are start from top leftmost, that particular element should be in the rightmost. When we move one to right, here also on one left it should be the same. When we move one more to the left, one more to the right, the left we move one more to left. So what we do is we move rightwards, and here we move leftwards. And what we try is to check that whether that particular element is equal. Okay, move left, right, and here we move left. Okay, we start from 0, here we start from and -1, and till the middle. But what about this, here also we start from 0, here also we start from n-1, then we move towards right, we move towards left, and we try to maintain the order that at the current left should be equal to the current right. This current left should be equal to the current right. This current left should be equal to the current right. And the one in the middle does not matter because there is nothing for it to compare. Okay. So from this we also get a particular conclusion, like from this one, above one, the middle one, that if it is palindrome and odd length, for this example A B C D C B A, we found that let's instead of D, let's take A here. B is 2 times, C is 2 times, A is 3 times. Let's take one more example. A B C A B C D C B A. In that case, we have found that A is 2 times, B is 2 times, C is 2 times, and D is only 1 time. This is a most important thing is that in odd length, the number which is in the middle, the number what you not the number but the character which is in the middle appears odd number of times. the number which appears in the middle is odd number of times, and all the rest appear even number of times. Why? Why? Because when we partition, we find that it is mirror image. So for when it becomes mirror, everything becomes twice, so it becomes even times. Here is the same case. Everything becomes mirror image, so everything becomes twice, but the middle element is itself the mirror, so it is not what you can say multiplied twice. So the what you can conclude is the element which is at the middle is what you can say odd number of times, or you can say the element which is odd number of times is in the middle. So what will happen if that odd number of element is not in the middle? Let's try a b c d c b. Okay, this. Now we try to put d somewhere else. If we keep d in the starting, a b c a c b, so now we will not be able to form palindrome because we had only one d, like a b c a. Now for to complete the palindromic subsequent string, we need one more d over here, but that d is consumed over here, so it cannot be formed. This permutation is incorrect. So what we make one conclusion is that okay, okay, let's make it like this. So we make one more conclusion that odd frequency character must have one element in middle. Let's see here. A is three times. A is three times. So one A is in the middle. Other two does not matter. Like when forming palindrome, it is important, but one of its element must be in the middle. Okay. So from this we get this this conclusion. And from this we have one conclusion as well. If it is even length, all elements have even frequency. Okay, all elements have even frequency. C is two times, B is two times, A is two times. Okay, after now we have found that even length have everything in the same frequency, or has one in odd frequency and other all are in even frequency. So the odd one must have one of its element in middle. Now what to do? Now what we will try is now what we will try is fix the middle and build from the edges. Let's take example, same example, odd length, and we will take for even as well. A B C D C B A. A B C D C B A. A is two times, B is two times, C is two times, and D is one time. So what we will do is we will first fix the D in the middle, and now we have three index over here and three index over here. Now what we will do is now we have one more condition. We want lexicographically smallest. Okay, we want lexicographically smallest. So why not? We then just put a. Why don't we just put just a second, guys? A over here, one more A over here. Then we have B. Then what we'll do is one more B is remaining. Then C and then C. We have found lexicographical smallest, but we have one more thing. It should be the palindromic permutation of S. So this will not work since this is A, because for smallest we have started with A. So now what you should do is we will put one A over here. Now both of our A's are exhausted. Now we will move to B. So we will put one more B over here, and to make it palindromic we put one B over here. Now both of our B's are also exhausted. Now it's time for C. Now here we put one C, but to balance the features of palindromic we put one more C over here. So what we are doing is we start from this position left and this right, and we put one occurrence of the smallest characters first and then reduce with. Here it was 2, so we put one A over here, one A over here, so both A got over. Now we move to this left, and now we move to this R. Now after A there is a chance of B, so we put B over here, we put one more B over here, and then the B got exhausted. Now C, and this B was already put. Now let's consider one more example of A B C A C B A. Okay, so A is 3, B is 2. This explanation, understanding part is the most important thing. If you guys understand it, you will be very easily be able to solve it. Since A has odd frequency, we have to put one A in the middle, and then we have three positions over here. We will start from L equals to 0 and R equals to n minus 1. We have smallest, so we put A, and to make it palindromic we put one more A over here. But we find that, oh, we have used 3 of our A's, so A is over. Now it's time for B. For smallest we put B over here. For palindromic we need to put B over here. Now B got exhausted, so to maintain the smallest we take the next grade, which is C. So we take C, and to maintain palindromic we take C over here. Now all our elements are exhausted, and this is what you can say one of the possible permutation of this. Suppose it was here. See. So this would also be remain same, and after following all the conditions we will get this answer, which is the smallest rearrangement or the permutation palindrome of S. Okay, but what about even length? Even length, let's take A B C C B A. A is twice, B is twice, C is twice. We will start from 0, A, and to maintain the palindromic we put A over here, and B, C, C, these are the extras. So we got the answer. Suppose it was like this: C, B, A, B, C. So this would remain same. We'll start from 0, and L equals to 0 and R equals to n minus 1. We'll put A. A will be exhausted. Then B. Then C. So we have to form the numbers like this, but our main concern is how. Now our next biggest question is how. How to do that? So we have two approaches. One is using sorting, and the another is using frequency error. Suppose we have, let's take for odd only, CBA A, okay, its length is 7, okay. So what we will do is, let's just first sort it. A, B, C, C. Now, since it is sorted, we know that we will take this one first so that lexicographically smallest order will be maintained. But we also want a palindromic. So if we insert at 0, we need to insert at n minus 1. If we insert at 1, we insert at n minus 2. Till when? Till middle. That, or you can say L is less than R. This, till this number. These three, and these three, we do not touch the middle. Okay. So we start from L equals to 0 and R equals to n minus 1. Okay. We, and in the sorted we start from A. We check. What we do is we check, is this A equals to this A? Like, are the both the elements equal? So for now both are same. So at A1A would be inserted over here and 1A would be inserted over here. Now should we consider this A? Because this A is consumed over here. This A is consumed over here. And this A is consumed over here. So these two A's are over. Now our next turn is A. This A. Okay. We will check that this A when can be paired with this, the next one. Because we want the two smallest and maintain the palindromic. But we find that, oh no, these both are different. So we also found that this is a odd one. This is an odd occurrence. So we put that A over here. You might be wondering, how is that possible that we found this A only as the odd one? Suppose after sorting we found out that it was A, B, C, C and D, D. Suppose this one, there was one palindrome, and when we sorted it we got this. So we exhausted this A over here. We exhausted this A over here and this A over here. And when we tried to pair this B with this C, we found that, oh, both are different. So we found out that the one on the left, that the current index which is not equal to the next one is the odd element. You might be considering, how is this possible? What if there was A, B? If this could also possible, that on the right one will be a odd character. So you might have also found out that there is only one element with odd frequency. There cannot be two characters with odd frequency, because if that was the case, it would not be palindrome. Like A, B, A. There could not be another number with odd frequency, because then it would not remain a palindrome. Otherwise, this condition would not be satisfied. That when partitioned from middle, it would be equal. So there could be only one element with odd frequency. Okay. So where were we? So if this happens, then you will be like, on the right one is the odd frequency, but it was already coupled with someone else when it was checked. So always the remaining one, or when unmatched, the left one was the, what you can say, the odd number. So we insert it over here. Now this B is exhausted. Now we check for this C. Sorry, here we were for this example, right? So these three A are exhausted. Now it is time for this B. We check with this B. Okay, both are correct. So we will insert one B over here, one B over here. Now it's time for C. So C and C. Now they are exhausted. Okay. Now let's take for E1. A, B, C, C, B, A is 2, B is 2, C is 2. Now what we do is sort A, B, B, C, C. We have 6 positions to fill. We start with A. Okay, we have one A and we have the next. We compare with next one. Okay, both are same. So we use one over here, one over here. B. Okay, B is with B. So we use one B over here, one B over here, and two C's. So one C over here, one C over here. So we got the smallest one. Okay. Now how we will implement is when we try for what you can say or it will be implemented for E1 as well. Okay. Just a second. Okay. So what we'll do is we'll start from index number 0. We check is current one equal to the next one. If that's the case, we inserted L and inserted R and we append 2. Now here we have A and we increment L by 1 and we decrement R by 1. Now we have A over here. We check it with this B. No, that's not the case. So we insert it in the middle. And when this happens, we increment by 1. We check it with this B. Okay, both are equal. Now this 0 L has become 2 and this is also decrement by 1. So okay, we insert one B over here and insert one B over here. We append this and we decrement this and we increment this by 2. When sorry guys. Let's make this smaller. When sorted I equals to sorted I plus 1, insert it L comma R, L plus plus, R minus minus, and I equal to I plus 2. Okay. And when sorted I not equals to sorted I plus 1, what we did was insert at mid. And what we do is add and L and R are not untouched and I equals to I plus 1. Okay. So let's implement this. Let's create a copy string m equals to s and we sort the temp strings can be sorted. Okay, sort temp dot begin, temp dot end. And the sorting time complexity is of n log n and it is working for 10 power 5. Okay, so it is well within the range. Now we iterate the temp and make changes in S. We initialize L with 0 and R with S dot length -1. Okay, we will do this till for int I equals to 0, I less than nums sorry, S dot. We are managing this increment operator, so as of now we will leave it. And also we need to make sure that if L equals to R or it increase, we will break it. Okay, because if L becomes equal to R, it means that we have reached the middle. Okay, now we will check if nums of I equals to nums of I plus 1. If that's the case, we S of L equals to nums I, S of R equals to nums I equals to I plus 2, L plus plus, R minus minus. Okay, I have one more clarification. What happens if the string consisted of only a single character, or it was A, B, B, and C? Okay, so in this case, what we should is, let's track and check. We are over here. We check it with A. Okay, this is same. So here it is A, here it is A. B 2 plus equals to 2. We are B, and here it is same. Okay, B, B. And here we are C, but there is nothing to compare over here. So what we can see is that we can check till this element, because in this case, if it was the case, let's take A, B, C, C. This is checked with here, so it comes A. This is checked with here, it will be inserted in the here. And when this is checked with here, C, C. So if a single element is at here, we need to keep one more check, like that it will not have any number to compare with. So we can check till here as well. So these two are checked. This was checked with this. So this single was checked. And when D2 is compared with here, so these two was checked. So we can say that our I is never reaching here. Okay, so in this case, that like what you can say, all the elements were checked, and as a result, I never reached here. What you can say, in the comparator I never reached over here. But in this case, comparator I reached over here, and it has nothing to compare over here. So what you can say is we will break at this point and check whether the comparator I is at n minus 1, or like in this case it is at n. If it is at n minus 1, if it is at n minus 1 here, if it is at n minus 1, we will add this in the middle. If it is at n minus 1, it means that all the elements have been checked. If it is at n, it means that one element is yet to be checked. Okay, but it was the minute thing which I missed. Let's get that over here. Okay, add and 0. Okay, there will be two consecutives, and due to some setup issues there would be some lag, and as a result the previous part had to be paused and the new session had to be started. So we add at the edges to maintain what you can say palindromic behavior. Okay, if that's not the case, means they are not equal. So int mid equals to, if what you can say L is at 0 and if length is 7, in this case length is 7, where do we insert the middle element? 0, 1, 2, 3. So 7 by 2. So int mid equals to, since L is incremented by 1 and R is decremented by 1, L plus R will always remain same, but we do not find mid this way. We do it by let's check once. If L was 1 and R was 5, uh, yeah, 1 by 2 will be 0, 5 minus 1, 4 by 2, which will be 2. Is that correct for the 0, 1, 2, 3? Even my maths is leaving me. Okay, it is, sorry. L plus R minus L by 2, which will be L minus L by 2 plus R by 2. Okay, so S of mid equals to nums I, and I equals to I plus 1. Now our final check will be if I double equals to S dot length minus 1, which is this, sorry, which is this, its length is 5 and our iter is at index 4, 0, 1, 2, 3, 4. It means that we need to put this one in the middle, the last element. So as a result, what we will have to do is we need to make I this block specific, main specific. So L and R. Let's do it simple one. It would be by 2 only, right? If its length was 7, it would be 6. So yeah, S of I by 2. Sorry, I by 2. Okay, S of mid equals to the last element, which was, it should not have been nums but temp instead. Temp of I, and then we return S. And this is correct. It should be correct. Yeah. So what you can say is that at this position I equals to S dot length minus 1 and this will happen only in odd cases. So if length was 7 and I would be 6, and we need to insert it at middle which is at 3 only. So in this case we can consider I by 2 only. Let's see the time complexity. It is very less. Why? Because we are doing off and log n over here. So let's move to alternate approach, which is using frequency array. Okay, and we have one constraint over here, which is that what is the constraint, that all are small case numbers. So at max there will be only 26 what you can say key pairs key. So it will be of 26, which can be considered as constant space only. So what we will do is, the way we have counted the frequency over here. Where is it? Okay. The way we have counted the frequency over here, what we'll do is we'll start from the smallest one, which is A or A over here. If it is odd, we insert one in the middle and the rest along the edges. Likewise, this is even, so we will move it along the edges only. Okay. So using map would also be the same, but inserting in map is might take a time. So we will just initialize what you can say a vector. We will name it as frequency. Its length will be 26, and initially all are marked 0. Okay. Now what we will do is we will iterate for. We will use the for each loop in S, and let's not use for each loop. And at that, which is val minus a, we will find the index using this and increment it by 1. And we will make changes in the S itself only. Now we will traverse the what you can say this frequency. I'll explain in detail in a while. Okay, so what we have done over here, we have initialized a frequency array of length 26, which is A will be at position 0, B will be at position 1, likewise Z will be at the position 25, and initialized each frequency with 0. Here that's why we have used 0 over here, and we will traverse the S. Okay, for suppose S was A B C D E, at this position val will be A, and val A minus A will be 0, so 0 point index we will increment. So v of A, or which is the counter of A, will increment by 1. Now it will be B minus A will be 1. B, what happens over here is that we consider ORD, what you can say ASCII values. Okay, now we check if V, that is the frequency. Oh, here it should be frequency. If frequency of I greater than 0, it means that that particular element is really present. That was a part. And we check if frequency of I mo- modulo 2 equals to 1. That is, we need to put one element in the middle. Okay. So what we will do is, uh, let's find mid. Mid will be nothing but, if it is equals to 1, we can consider that it has odd length, and the length by 2 will be its mid. S dot length by 2, and we will put that element in S of mid. Let's create one string answer, string 10 question, and this time we will put it in the 10. Temp of mid equals to mm, A plus I. Okay, and we will decrement by 1 frequency of I minus minus. Okay, now all are even. Now these numbers become even. Now what we will do is, okay, we need L over here as well. L equals to 0, R equals to S dot length minus 1. Okay, so while L less than equals to R and that frequency is greater than 0, what we'll do is temp I equals to A plus I, not temp I, temp L, sorry, temp L, and temp R also equals to A plus I, L plus plus, I minus minus, two of its frequencies are used, frequency I minus equals to 2. Okay, now after this is done, we increment I. Okay, I is incremented over here only. So let's check once. Here it is the frequency. We increment. Okay, what is the issue? Okay, we have to return. We will return the temp because we have made changes in the temp. So we make frequency error over here. If it is greater than 0, if it is modular, there is only one possible middle odd number. So we first put it in the middle and decrement it. Okay, now you can see the time complexity. It is the best. We have done this in off and time, and we have used zero extra space, or you can say off one only because we have used 26 extra space. You can consider 26 extra variables. Okay, so I hope you guys enjoyed it, understood it, found the pattern, and yeah, if you have any suggestion, do let me know. I know the video was lengthy, but the explanation was very required. The Excalibur is in the caption.